making salts has three different methods depending on what is the state of the salt, like soluble or insoluble, and to prepare that salt, what is the state of the reactants? The state of the reactant and state of the product, salt. This will decide which method will you choose. So there are three methods basically. So one is neutralization, second is titration, and third is precipitation. Out of which neutralization and titration, these two are used to make soluble salts. Okay, so these two are used to make soluble salts. And precipitation to make insoluble salt. Then what is the difference between neutralization and titration? The similarity in both the methods is that in both the methods, the reactant will be acid and base. So acid plus base gives you salt plus water. And this also acid plus base gives you salt plus water. As we discussed earlier, in both the cases, the salt will be soluble, so aqueous salt. Acids are always aqueous, soluble. Water is liquid. The difference between the two methods is that neutralization means the base is insoluble, which means solid. In titration, the base is also soluble. Alright, so that's the difference between the two methods. So to make a soluble salt, you always use acid plus base. If the base is insoluble, then use neutralization. If the base is soluble, then use titration. To make the soluble salts, the methods are neutralization and titration. If the base is insoluble, then use neutralization. If the base is soluble, then use titration. So what happens here? In the neutralization, when the base is insoluble, if the base is insoluble, then you add excess of this base to the acid. So add excess of base to the acid. Why should we add excess of base to the acid? So that all the acid is used up. Okay, but the base is not used up. Base is added in excess, matlab some base will be remaining unreacted. So what do I do about that base which is unreacted? You filter out. You filter out excess unreacted base. So step number one, make sure that all the acid is gone. Use the step number two, make sure that all the excess base is gone. So now I have only salt and water left. I want salt out of that. So which means I don't want water. So what should be my third step? To remove water. Heat. The filtrate, because when I filter, this will be in the residue. This will be in the filtrate. So heat the filtrate. How long to heat? Keep on heating. Then heat the filtrate till crystallization point, or also called a saturation point. How do I come to know when the crystallization point has occurred?
Glass rod.
The glass rod test. You dip the glass rod in the hot solution and take it out. If the glass rod has crystals formed on it, which means the solution is already saturated. Now you're going to heat, continue heating, stop heating. Okay, once you stop heating, the solution will cool. As the solution cools, the crystals will start forming. Heat the filtrative crystallization point. Allow crystals to form. As solution cools. Why will the crystals form as the solution cools? Because the solubility of the solution decreases. Listen, when the temperature decreases, solubility decreases. Temperature increases, solubility decreases. Hot solution, more solubility. Cold solution, less solubility. Because the solution is coming from like hot to cold, so solubility is decreasing. Matlab the whatever salt it has dissolved in it, once it becomes cool, it can't dissolve all that salt, so solubility has decreased. So it needs to undissolve that. Undissolve matlab crystallize. So crystallize are that dissolved solid which has got undissolved because now the solubility has decreased. Okay, so allow crystals to form as solution cools. Now I got the crystals. Now filter the crystals and dab dry using filter paper. Okay, so you need to dry the crystals using filter. We'll take the example of this. If I have copper oxide plus sulfuric acid, gives you copper sulfate plus water. Copper sulfate, copper oxide is metal oxide. Metal oxides are basic oxides. All metal oxides are basic oxides. All? Which ones are not? Aluminium oxide and zinc oxide. They are not basic. So what are they?
They are both.
What is that called?
Amphoteric.
Amphoteric. Anyway, so copper oxide is not in the amphoteric list. So copper oxide is a basic oxide. And that's insoluble. Sulfuric acid is soluble. Copper sulfate or salt is soluble. Water is liquid. What should I do? They will give in the question. Okay, now what should I do? Step 1.
Add excess.
Yeah. Add excess of copper oxide to sulfuric acid. Step 2. Filter off the unreacted copper oxide.
Yeah.
So H2SO4 used up, copper oxide removed. Now I have copper sulfate solution. Next step. Heat the crystallization point. Allow crystals to form. Once the crystals are formed, dab dry, filter the crystals and dab dry using filter. Matlab, once you stop heating, it will cool. No? Alright? So next is titration. When I have acid and base both soluble. So can I add excess of base to the acid? Or excess of acid to the base? No, because both are aqueous. So anything which is excess will remain unreacted and that will be there in the final product salt, because salt is also aqueous solution. So I cannot add anything in excess. I have to add both of them in the correct amount. So how do I add both of them in the correct amount? You do the titration method. What do you do in the titration method? You add acid to the base using the burette and the conical flask setup. So you take the take the burette and you take conical flask. Suppose that you take acid in this, but known volume. Suppose 25 centimeter cube, known volume, and then add indicator to this. Then you add drop by drop base from the burette. When you add base from the burette, before you add, you have to take the initial reading. Then when you add, keep on adding till the color changes. The color change matlab all the acid is used up. All the acid is used up, stop adding. But this level would have come down. I take the final reading. Okay, so final minus initial will give you how much of the base I have added. What volume of base I have added, I will come to know. Let's say this is x centimeter cube. So now I know that x centimeter cube base has to be added to 25 centimeter cube of acid. Then I repeat the experiment without the indicator. But this time I know how much to add. I don't need the indicator. So I add that much. I add x centimeter cube to 25. And I know that this has neither acid nor base in it. Both have been used up. So once I repeat the experiment without the indicator, I will have the salt solution, only salt solution here. Because neither acid nor base is there. Both are used up. So once you have only salt solution, then this step 3, 4, 5, you can repeat here. Heat the solution till crystallization point, allow crystals to form, filter the crystals and tap dry using filter bed. This you can get for in paper 4 also, paper 6. Okay, so titration ऐसे होगा. HCl plus NaOH gives NaCl plus H2. HCl aqueous solution, NaOH alkali है तो base soluble base है, sodium chloride is soluble salt, water is liquid. How do I start the experiment?
First, the titration method. You use a burette and a flask. And you
So what to add in burette, what to add in a flask?
acid in the.
You can add anything in acid, but the color of the indicator will change accordingly.
Then you add the.
Suppose that you are adding acid in the burette.
Yeah.
And base in the conical flask. Now
You add the indicator to the conical.
base in the conical flask has to be known volume.
Yeah, no volume.
Like 25 centimeter cube. Then add indicator to that. Okay.
Then the droplets go into that.
Then from the burette add drop by drop the acid till the color changes.
Yeah.
Okay, when the color changes, stop adding and take the readings of the HCl. How much added?
Then
So now you know that 25 centimeter cube of this, suppose 24.3 centimeter cube of this reactor.
Yeah.
Okay. Then you discard the solution, repeat the experiment using these known volumes without the indicator.
now
Now both are not there. Use
Yeah,
the only
we
salt
use the-
solution. So you can simply heat the solution to crystallization point, allow crystals to form as the solution cools, filter the crystals and tap dry using filter. You don't remove the indicator. The second time you don't add the indicator. Because now you know how much to add. Now, why was the indicator taken? To know how much to add. Huh? Because there is an indicator inside it. If I crystallize that, I will get the salt along with the indicator. So I have to, that's why I have to discard that and repeat the experiment. It has to be pure, the salt has to be pure. Okay, now about precipitation method. Remember that इसमें always the salt is insoluble. And you often make this from two different salts. Salt plus salt gives you salt plus salt.
Yeah.
Okay, like AX plus BY will give you AY plus BX. This may say AY is insoluble, BX is soluble, and both the reactant must be soluble. So only one insoluble product. Now, what happens is that because the product is insoluble and which is at different state than both the reactants are soluble, product is insoluble. So you can add them in any amount, like you don't need to worry about whose X is or using the indicator, nothing. You can just simply mix them. This is the simplest method, just mix the two solutions. When you mix the two solutions, they will form these two products. You can see this will be insoluble. So solid, this is solid, insoluble, but this is the precipitate. Next step I will simply filter this So this insoluble salt will come here. And the other products will go here. I want this to make it pure, to remove any soluble impurities. Next step, I will add distilled water, which is called as washing. Washing के लिए I will add distilled water, so this will not dissolve. This is insoluble, but उसमें जो भी soluble impurities है that will rain down. So now I have a pure substance, pure precipitate, but it is wet. It is wet. So no, this you will not that dry. You will heat in the oven. Okay, you will heat in the oven at low temperature. Bad oven. Alright. So when the salt is only insoluble, then simply mix the two solutions. The separate will get filter, wash, dry. Okay, that's it. Now इसमें if suppose I have to make silver iodide, I will take two compounds here. What is the state of silver iodide?
Solid form.
Insoluble, so solid है. The two compounds here. See, I need two ions here, silver ions and the iodide ions. One compound will give me silver, other compound will give me iodide. Matlab this will be silver something and this is something iodide. Like AX plus BY.
You take any?
No, you can't. You can't take any. So I'm just talking about that. AX plus BY. Understood this? Okay. But what is the condition of the both the reactions? They must be soluble. That's the condition. So which silver compounds are water soluble? We don't know. So it's best to take nitrate. Always, any compound, if you want soluble and you have the cations, then anion may take nitrate, all nitrates are soluble. Here, some iodide compound which has to be soluble now. Which iodides are soluble? We don't know. But we know one thing that all the group 1 compounds are soluble. So take any group 1 metal here, potassium or sodium. Okay, all group 1s are soluble, all nitrates are soluble. So if you want to choose a cation which will make the compound soluble, choose group 1, potassium, sodium. If you want to choose an anion that will make the compound soluble, choose nitrate. What is the other product?
Potassium nitrate.
Now this is definitely soluble.
Yeah.
How do you say that potassium nitrate is soluble? Because nitrates, all nitrates are soluble. Cation is potassium, all group 1s are soluble. So two reasons to call it. Okay, now I have to make silver iodide. What do I do? Step by step. Mix the two solutions. Precipitable form. Then filter. Next,
Distilled water.
wash with distilled water.
Then take. You will
Fry in the oven at high float. All right.